lesson on finding oxidation numbers. Oxidation numbers are essential in chemistry for understanding electron transfer and redox reactions. Let's start with the basic rules for assigning oxidation numbers. Rule 1. The oxidation number of a free, uncombined element is always 0. Rule 2. For monatomic ions, the oxidation number equals the charge on the ion. Rule 3. The sum of oxidation numbers in a neutral compound equals 0. There are also some elements that usually have fixed oxidation numbers. Group 1 metals are +1, group 2 metals are +2, fluorine is always -1. And hydrogen is usually +1 except in metal hydrides, where it's -1. Let's look at our first example. Finding oxidation numbers in water, H₂O. We know hydrogen is usually +1, and the molecule is neutral, so the sum must equal 0. With 2 hydrogens at +1 each, oxygen must be -2 to balance out. Let's try a more complex example. The sulfate ion, SO4 superscript 2. We know the overall charge is -2, and each oxygen is -2. With 4 oxygens at -2 each, that's -8. The total charge is -2, so sulfur must be +6 to balance. Now let's look at potassium permanganate, KMnO4. We know potassium is +1 as it's a group 1 metal, and oxygen is -2. With 4 oxygens at -2 and 1 potassium at +1, manganese must be +7 to make the sum 0. Let's do one final example. The dichromate ion, Cr2O7 superscript 2. We have 7 oxygens at -2 each, that's -14. The overall charge is -2, with 2 chromium atoms sharing the remaining +12 charge. Each chromium must be +6. Let's summarize the key points for finding oxidation numbers. Remember the basic rules, know the common fixed oxidation numbers, and make sure the sum equals the overall charge of the molecule or ion. Practice these rules with different compounds, and you'll become proficient at assigning oxidation numbers.